Mel the Engineering Geezer back, and I've got something different this week. It's going to be a longer project, but lots of small parts on this. So it's going to be short videos on this one there. I hope you enjoy it. And the way we can do it is give it a go. Mel the Geezer's back. He's going to be having a go at producing one of these, but not exactly as is. The essence will be the same, but it'll be my design. What I plan to do is to get rid of this manifold type here, change the style of these, and also instead of using countersunk screws in there, we're going to encapsulate a nut in there where you can screw a cap head all the way in, and it will mount these two side cylinder brackets onto the main base. What I will be doing is doubling the size. Now this is an image of this particular assembly. I found this on GrabCAD, originally designed by this J. Donnerberg in 1992. So someone done that in 2022 and got this running on YouTube. You can find it. I'll put a link to it later. You can see the original drawings, because it's a American university, everything's in imperial. I live in England, we'll be making in metric. So there you see, that's the bush for the crank. There's the flywheel, again, various bits and pieces. These are the side brackets, the cylinder brackets that bolt on. You can just see the way it's been sectioned off. You'll see this is a countersunk screw bit there. Personally, I would have used a call out on this one there, but 1991 CAD was not as good as what it is today. There's the pistons, the cylinders that we have there. So it pivots on this part here, and the air comes in and exhausts out the same port. And there's the cranks there. I will be shaping this, not going to leave it as a disc. And there's the base. What I will be doing is that I'll be doubling the size. So this 2.375 is just over 60 mil. So we're going to make ours 120 mil long. Overall height, double that height there. Is the width, we're going to double that. Now, if you look closely, I'm just going to zoom in on the image. You can see that if we are to 3D print this sharp corner here is not going to help, and these sharp corners here are not going to help. So these are problematic. So we'll be doing something in there to improve the design, knock off that sharp corner there. And if you look at the sides there, back of it, and if you look at the plan view or the top view, corners here, so I'm going to round those off as well, as we see there. So I'm going to make it twice as big, so you can see that, and 3D print the whole lot. So this is what I've done so far. So there's the original models. Okay, now I've left one transparent on. One part's going to be transparent, and you can see the pneumatic elbow fitting here. That fits there, so the air comes in. If I spin the crank in this position, this as the piston gets forced up, air will exhaust out of the top port. And as I rotate that back to this one, as it spins, the air inlet port is now exposed, and air will be pushed in there, and that will continue the cycle of piston in, piston out. So when this piston's in, this one's out, 180 degree opposed. So one's in, when one piston's in, the second cylinder is out. That's what I'm planning to do. And just take that transparency off. There we see there. And these fittings here, if you haven't heard of them before, I'd get yourself over to Trace Parts. This is where I find all my parts. They are not sponsored by anybody in this video. So if you go to the design library, you'll be able to scroll down this, and you'll be able to see all the manufacturers. So if you look at see all catalogs, you can choose whoever you want to do that. So if we go to S for SMC, just scroll down there, you have all the manufacturers who are involved with this. I'm going to go to SMC, just scroll down, or you can actually click the side. Hopefully that might work. SMC. There are SMC. Click on that, and you'll get all the actuators, fittings and tubing, fittings, one-touch fittings, and you can then choose whichever one you want from there. So looking for what you need. You're looking for M5 fitting, but that has got a 6mm hole. So if I go back one, that's one way. That's one way of getting your fittings. Or you can go at Browse Content, Pneumatics, and look for the fittings, and you can see all the adapters that you would require. Okay, even got those with the where is it? Even got those with the flow control valve on top as well, if you want to control the speed on it. Saves you putting in an additional valve to do the same job. Not bad. So you can see that's what I'm planning to do for this week here. It's a short video this week. See that? So let's turn that around the other way. You can see those pistons going out on the Solidworks. So what I do is I'm going to show you how to design each part, assemble it. So what I do, make a couple of parts, start putting them together, get your bits and bobs, the fixtures and fittings, where I got this from, which I've already shown you, and we'll put that together and 3D print it. Eventually, if I get the tolerances correct, we'll be able to run this with the care as well. So all I need is another valve to let me run this as we go from there. So what have you let yourselves in for? Okay, so after we've done the printing, you can see the base, two cylinder brackets there, the cylinders are here, a couple of pistons, some bushes. Obviously you can see the flywheel here, excuse the shadow. The cranks, it tells you they weren't going to be round, so that's what I'm going to do. You see a little bit there, that is the grub screws that are going to hold the cranks on. There's another grub screw that goes on this one, some cap head screws, some nylock nuts, and a bit of ground bar, which is 100mm long, to go through the whole lot. So that's the bar. So that's the bar that's going to go from all the way through that bit there. Okay, and there's a grub screw that screws onto that, into that, and into the last one there. So tools that you'll need. You want some files, reamers, some deburrings for the hole, drills, some taps. There's an M6 tap and an M4 tap, and obviously I've got a vernier there, a rule up there, some Allen keys, obviously my trusty calculator. Never forget the pen and the paper. Take your notes, do some sketches as you're drawing it, and away we go. So that's what you're letting yourselves in for. I'm going to do short videos for this one here. It's going to be a lot easier to follow. We're going to start off with the base, the cylinder brackets that you see there, then the bushes, which are going to go all the way through. We'll stick the shaft on with the flywheel, cranks at the end, bolt them all up, make sure that's running nice and easy through here, and then we can then start thinking about putting the last few parts on there to get that sorted. I've yet to order the two adapters. They go underneath. It's going to go in here. So there you go. So we've got some debris I've got to take out of there. That's some support. That's what it should look like, all nice and clean. Oops, a daisy. There we are. There's the ports. The ports might be too big. We don't know, but we'll soon find out when we do the first prototype. The good thing about it, when you're 3D printing, if there is something that needs to be changed, you change the model, create a new STL file, and off you go. Print it again, and then try again. Quite a lot of us have actually had do the prototypes and machine all the parts first and try it. So if you had to wait 8 to 12 weeks for lead time for parts to be made and something was wrong, you're going to be a little bit annoyed or get embarrassed by your workmates as well. So at least this way you can print out, try it, have a general feel of it, and there's something not quite right with the design, you can change it there and then and print another one up. I think the longest print was this one here. I think that's like 3.5 hours or something like that. Maybe even less than that on the Creality K1. So you say you got these are just simple hand tools. You put the whole lot together, deburring, take the fuzz off, bits and bobs, and that'll be all good. Hopefully you visualize what I am actually going to do. The two-cylinder piston engine is quite a nice thing to do. You get to play around with your limits and fits with the 3D printing part of it, so you get actual things working. We will be looking at how we attach things together. I will be using metal parts in there and using hand tools to make sure it works there. And hopefully, as soon as I put the air on, it should run. Okay. The other thing is the flywheel's made out of plastic. It might not have enough there to actual spin. So what I might do is produce another flywheel with some better inserts, and that will give it inertia to keep it rolling. So, you know, I've got these things thinking about as I go along. Right, that's the first part we're going to do. I was going to show you. That's the first part we're going to do. Okay, you can see it's quite a nice size on there. By the time we got the extra bit on, you can now start to see it's going to be quite a nice assembly. I'll put the second on. And you can see that's this chassis, if you want to call it the chassis, as you say from there. But we'll do that next week. These the week after, with the bushes that locate this all together, and then we'll bolt those together, and I'll show you that. I'm not going to show you everything now, okay? So you'll see how things are done. So if you are doing anything 3D printing, you might be able to transfer some of the skills you learned on this to enable you to do something else. I have some other inserts and stuff like that I can use. I want to use that for another project, which is going to be a little bit more, well, it's actually going to be more complex, and the tolerances we'll have to mess around with on that. But let's do this one first. Okay, so as always, over and out. See you out and about. Toodle pip.